This is a message to the planet.
Why not?
Why not defy the odds? Why not connect numbers, science, law, and diplomacy to show what's been hidden for too long? Some places get hotter, some can't breathe, some suffer in silence. Climate change is not equal. This is Fault Line, the heat divide, and we're here to prove the truth. One graph, one autopsy, one law at a time.
Beneath every crisis is a pattern, numbers that whisper truth before the damage is done. We don't just feel the heat, we can calculate it, we can trace it, across decades, across continents, until it draws a curve that doesn't lie. Now to our math expert, Yahya and his colleagues, as they decode the numbers behind the heat. Yahya is an experienced mathematician. He's worked overseas, searching for patterns, decoding climate curves, and modeling the future we're heading toward. Now, he's bringing that expertise to this investigation. With every data point, he's warning us. This isn't just numbers, it's a forecast of crisis. And Yahya's here to show exactly what the math reveals.
We started by modeling the short price of carbon dioxide in the atmosphere. The function C multiplied by T equals C times e to the power of kt, where T is the number of years since 1958.
It looks simple, just a curve on a graph. But this equation isn't just math, it's history, it's damage, calculated. Each letter in Yahya's function holds weight. C0, the CO2 levels when the world thought climate change was science fiction. K, the rate at which we've been heating the planet without even noticing. And T is the time we've wasted. Yahya's model doesn't predict the future, it records our failure to stop it. In 1958, CO2 was just over 315 parts per million. Today, we're above 420. That's not a fluctuation, that's an exponential crisis. We've mapped the exponential rise. Now it's time to see what that rise really means. To do that, we turn to the logarithmic model, with Adele, Jonathan, and Saif leading the way.
We connected carbon dioxide levels to global temperature using logarithmic model. T equals A multiplied by log to C plus B. And what we found was clear. Even small increases in CO2 can lead to big spikes in heat.
We modeled emergency room visits for heat-related skin issues like eczema and melasma using ST equals 12 times e to the power of 0.08 t. That's an 8% increase every year.
We graphed where this hits 50 visits per month. Around year 17, we hit that mark.
And solving for 60 visits, 60 equals 12 times e to the power of 0.08 t transforms into t equals ln multiplied by 5 over 0.08, which equals to 20.12 years. That's a near doubling in 2 decades.
The math showed us the pattern, but numbers alone don't tell the whole story. For that, we turn to the evidence. Now, Adele takes us from the graph to the body.
Case 081, Logan Costa, age 62, found dead during a heat wave, but something didn't add up. We followed strict forensic protocol, sealed evidence, control samples, clean tools. Blood analysis showed toxic cadmium and lead way above safety limits. His oxygen levels 86%. That alone can lead to collapse. Hair samples revealed fine metal dust. Clothing fibers matched particles from a nearby refinery. This wasn't surface exposure, it had built up over time. That's pharmacokinetics, how toxins enter and build in the body. And pharmacodynamics, that's how they damage it. Logan's lungs were inflamed, his heart strained, his body couldn't cool itself. This wasn't just a heat stroke, The environment slowly poisoned him. The heat wave just made it fatal.
Before death, the skin suffers. And few understand that better than our expert, Jonathan. He couldn't appear on camera, not for secrecy, but because he's buried deep in the data. And that's where the truth is.
Our skin protects us, but it's under attack. The epidermis has keratinocytes and melanocytes to fight UV rays, but tiny pollutants break through, causing oxidative stress. This breaks down collagen in the dermis. That leads to eczema, melasma, sunburn, worse in the urban heat islands. In polluted, overheated cities, skin-related ER visits rose 38% in the last decade. Heat and toxins also weaken the skin's immune defense, making infections and inflammation more common. The climate crisis doesn't just change the weather, it damages the human body, layer by layer.
The skin shows the damage, but the cause goes far beyond the body. Now Ahmad, Abdallah and Kareem take us global to expose the politics behind the pain. We start with Kareem, a strategist, a designer, and a mastermind of modern diplomacy. As the world heats up, he's charting the fault lines where climate meets conflict.
The air pollution crisis shows what happens when global cooperation fails. Over 90% of the world's population breathes air that exceeds WHO pollution limits.
Transboundary pollution is a growing issue. For example, pollutants from industrial zones in one country can drift across borders, worsening air quality elsewhere.
While the Paris Accord focuses on CO2, it overlooks other toxic pollutants. PM2.5, a fine particulate, causes over 4.2 million premature deaths per year. Low-income nations often lack clean tech and enforcement power. The results? Poor air quality and little say in global negotiations.
We used an exponential growth model to examine the link between urbanization and pollution. If current trends continue, PM2.5 emissions in some cities could double by 2050.
Air pollution also damages skin health. Chronic exposure increases chances of premature aging, eczema, and even skin cancer, especially in high UV, high pollution zones.
Vulnerable groups like outdoor workers and people in dense urban areas face higher risk of respiratory and cardiovascular illness.
The air crisis isn't just environmental, it's international, and Abdallah brings that truth to the UN stage.
We must invest in air filtration systems, urban green zones, and smart pollution trackings. Without action, the air crisis could rival climate change in severity.
Global action starts with global awareness. That's where design becomes power, and Kareem knows exactly how to use it.
We built a website not just to inform, but to act. It has interactive graphs of disease data, full forensic case files, air pollution data and report, anatomy visuals, and scientific research, and finally, a call to action page.
We've done the math, ran the tests, read the laws, and told the story.